If you are ready, thank you so much to everyone who is, thumbs up from Caleb, who is here today. You may have heard Katie, who just dropped, I believe, mention that webinar is being recorded and streaming live to Facebook. Just as a heads up, it is live now. So if you are comfortable with your face being on, we would love to see your smiling face, but just know that that is happening. So if you're not, now is a great time to shut that camera off. I am Morgan Boykin. I am our volunteer and community coordinator with SC Code. So I work with volunteers across our platform who help our learners. For those of you who are new to SC Codes, in my little swag promotion here, SC Codes in general, we are a free platform and resource for South Carolina residents to gain coding skills. So we have classes on our platform, courses on our platforms that are self-guided as well as instructor-led that are meant to help you gain coding skills, skill up, or explore coding as a possible career opportunity, change, or investment for yourself. So again, I'm Morgan. I am here just to kick off our webinar today, which is entitled Clean Code. You are in wonderful hands with our instructor for the afternoon. I was going to say evening, but not going to be that long. Quick afternoon session with Caleb. Caleb works on our platform as a mentor and also our curriculum consultant. So he is all things in and outs of how our curriculum works, what's in it, and how to utilize it. So Caleb is going to be teaching you all this afternoon. I will allow him to introduce himself and give you all some really great details about himself. I'm sure he has a ton that he can share before he jumps into the actual webinar, but just a couple of reminders before we get started. Cameras on if you are able and interested. Again, another reminder that we are streaming live on Facebook in case that is an issue for you. Please feel free to utilize the chat at the bottom with any questions that you may have, as well as any questions that you may have about SC Codes. I'll be hanging out and can answer those questions for you as well. And also, please make sure to come back to our events page, our social media, our web page to catch other webinars that are happening throughout the summer. We try to host a couple every month for you that range in different topics. So if there's something that sparks your interest, we would love to have you back here. So without further ado, I will turn it over to the awesome Caleb, and good luck and congratulations everybody for skilling up, spending your afternoon gaining some skills, and I hope to see you across our platform.
Thank you so much, Morgan. As Morgan said, I am Caleb McQuaid, a mentor with SE Codes. I am currently working for a company called Enok Collective in Greenville, South Carolina. I'm a Greenville native, so been in South Carolina pretty much my entire life. But I'm super excited to talk to you all today about clean code. And just to give you a little overview of what we're going to be discussing today, clean code is kind of a discipline of software engineering, software development. It's not exactly something that you might learn right at the beginning. It's not overly taught, but I have joined Enok Collective, and they are a big proponent of clean code, and they really push that in the services they offer and the work that they do. So I'm going to share my screen and we will hop right in here. So just from the start, just want to give some credit to the folks at Enok. This whole talk and PowerPoint slide was designed by the folks at Enok, specifically Chandler Roth, and they have allowed me to use this, so big credit to them. But we're going to be talking about clean code, and clean code is essentially just that. It's not dirty, it's not messy, and while yes, all software is a little messy, today we're going to be talking about how to kind of clean that up a little bit and how to get some best practices in writing code. A little about myself. I am 28, I think. Lived in Greenville my whole life. That is my beautiful wife there, Linnell. We are expecting our first child in July, so we are super excited about that. But I joined Enok Collective as a software apprentice back in September of 2020. And I've been doing software development for about 3 years now. But honestly, the things that I'm learning as an apprentice and the things that I'm being mentored in, and some of the things that we'll be talking about today are things that I wish that I had learned at the very beginning to kind of set those best habits, best practices. So Enok is a software development company. They are originally out of Peoria, Illinois, but they are starting to expand, and they now have a hub in Greenville, a hub still up in Illinois, and a hub in Nashville. But we are a consultancy, so companies will come to us and say, hey, we might have an idea for a product. We have an existing product right now that we need help with, or somewhere in the middle there. And we loan out our engineers to help them with those products. Enok has about 12 years of experience in software. They write in a bunch of different languages and have served a lot of different clients, including one of the sites that is in like the top 100 sites in the world as far as page visits. So they know their stuff. It's a good company to be working for. This is the crew right here. A lot of swell people here that I've gotten to know. So let's dive right in. What is dirty code? And dirty code is code that might be difficult to understand. The computer can read everything that you put into your code editor to a certain degree. If you've ever seen an error before, that might be the computer saying, hey, I don't know what this is. I don't know what you were trying to do, but I can't read it. But it will try to read everything. So the computer doesn't care if your code is dirty or clean or somewhere in between. It will read it all, and eventually it will hopefully give you some kind of response. But the computer isn't the only thing that's reading our code. Typically, you'll be working on a team of some kind, or the code that you write might end up in somebody else's hands down the line. It is very infrequent that the code that you write affects no one other than just yourself, whether it be other teammates or the customer or the consumer of the product, or even your future self. You will probably be coming back to that code. So clean code is a way to write human readable and human understandable code so that people aren't confused in the future. Mark Andreessen is a tech investor. He was very involved with the start of the internet, and he was a big player in there. And you may have heard this quote, but he says, software is eating the world. And essentially what he means by that is that everything we touch has something to do with software, whether it be the phone or the device that you're using right now, that's definitely using software, to the car that you drive, to, a refrigerator might have software on it. So software is eating the world. And if we make that software very dirty, we're going to get a dirty, nasty experience, and some bad consequences because of that. So let's hop right into some code. If anyone can read this and understand this, they are a much better programmer than I am. This is a simple function, and the title of this function is rental car cost. So that kind of describes what we're going to be dealing with here. But after that, we've got days of hurricanes, and then we've got a bunch of letters and numbers and all kinds of random junk in there that I can't really read right off the bat. So we're going to come back to this, but this is an example of what might be considered dirty code. This is going to be difficult for someone else to understand. The computer will understand this perfectly fine. and it will run it, and it will hopefully give us the right response. But again, the computer isn't the only one that's reading our code. And let's talk about who this affects, really. At this point in time, it's only affecting, if I were to write this right now, this is only affecting me. And maybe it might affect my teammate a little bit when they come to use the code and they say, this is really difficult to understand. I've got to spend some time really taking it apart and parsing it out. And maybe I've got to talk to Caleb because, Caleb, you wrote some really confusing code. I don't understand this. And then this is really long and complicated, and maybe there's a bug in there that makes the software run really slow. So, our users end up suffering. And then this all boils down to the company that we're writing this for. It costs them time and money to pay the employees to figure out this code, to write this code. It might cost the company when the users experience a slow product and say, you know what, I'm just not going to use this anymore. So this is just one, 41 line function, not that big of a deal. But when it starts compounding, we also see the pain compounding for all of those different parties until you have a giant code base that is just a mess, and you are very confused, and everything you touch kind of breaks something else, and fires start and everyone's up in arms, and everyone's really unhappy. So let's not do that. Let's write some clean code instead of some dirty code. Some real world tragedies that have happened because of errors in programming. Specifically, there was a blackout in early 2000s in New York City that lasted for several days. That was due to a software problem. There have been some pretty high profile issues with Boeing's new jets. They have had some serious issues and some serious crashes, and those have boiled down to software problems. And people have lost their lives because of that. There have been banking issues where money has been sent to the wrong place because of a software problem. And these have all happened within the last 20 years. So while you might think that, oh, my code doesn't really affect anyone else other than me, and it's not that big of a deal, this can be a very big deal in the long run. So let's deal with the problems of dirty code. You will feel pain when you come back the next day and you write that and you just kind of cringe and you say, oh, I don't like that. I don't like how that looks. I don't like how that runs. You'll feel the pain of that. It'll be hard to maintain, and your team will feel the pain of that. We've covered some of these already. The users will feel pain, and the company will feel pain when they have to pay you to rewrite the code again, or someone else. All of this to say is dirty code is costly. It's costly to everyone involved. Something to go along with this talk is the concept of automated testing and test-driven development. And that's how I'm going to start off the conversation around clean code. You might say, how do I know whether my code is dirty or not? And we'll talk about some of those, how you kind of figure that out later. But a good way to test whether your code is clean or dirty is to use these other disciplines of automated testing and test-driven development. I won't spend a ton of time on these, but essentially, we use software to test our software. And we'll write code that affirms what we think should happen with our code. And then every time we make a change to our code, we'll run those tests. And those tests will come back and say, hey, you're good, everything's working the way it should be. Or it'll come back and say, no, you've got a problem here. And that kind of helps us, as every incremental step that we take in our software development will have that thumbs up from our code to say, yep, you're doing a great job. All right, so clean code is not dirty code, but it is also human readable code. It should be understandable. It should be, less, more pain-free, should we say. Um, as we said, computers don't care about your code. If it will run, the computer will run it, no problem, no questions asked. So the source code is essentially for humans. It's for that next person coming down the line. So how do we write something that, we are sure that someone else is going to understand? We want things to be simple. We want things to be consistent, tidy, readable, and testable. So let's go back to our example of dirty code here. Here we go. Okay, so we've got this function, and it is not simple. You've got kind of some nested functionality inside this original function. It's a really long function. We've got some variables here that just have 2 letters. This variable only has 1 letter. We have these numbers that don't really make much sense. And we've got these less than and equal to signs, and just, it's not understandable. It's not simple. This is very complex. It's not entirely tidy. This doesn't have a really good flow to it. It's not super readable. It's not consistent. And yeah, just it hits all of the opposite boxes for our clean code here. It's none of these things. So to start out, one of the easiest things that I feel is a good start for writing clean code is to use clear names. Now you might think that it's easier to name a variable just 1 letter or 2 letters, and you think, oh, I'll remember that when I come back to it. You probably won't. I'll tell you that right now. So to use clear, consistent, long names will help you in the long run. And a little tip around that: if you're writing a class or a property or a variable, use a noun. If you're using a method or a function or some kind of action, use a verb. And that's just a good English tip there for you. So we have 2 examples here. So we have our first variable, and we've named it y. We've set it equal to 74 here. The next person is going to come along and they're going to say, I don't know what y stands for. But on this second line here, we've named the variable height in inches. I know exactly what that means. There's no question about, is the height in centimeters? Is it in meters? Is it in miles? Height in inches, very descriptive, very consistent, very readable. Here's another example of a function. This is coordinates, great, and we've named it place. I don't really know what that means, but we have this really long name here, but it's very descriptive. And you might say, like, well, is that less performative? Isn't place a smaller name? It's easier for the computer to read. The amount of characters really doesn't matter unless you are dealing with an extremely large code base. The time that it will take the computer to read place versus get treasure GPS coordinates is going to be extremely minimal. You will not notice the difference there. But the person that comes after you is definitely going to notice the difference in time there. Tip number 2, you might have seen the word dry in your coding learning, and that is anagram. I don't remember the correct word for that, but an acronym. But it stands for don't repeat yourself. So as much as possible, if you find yourself writing the same variable, the same function, something like that, try to make it as global as possible, and then take that reusable function, that reusable variable, and reuse it elsewhere. This will help your program be more performative, and it just introduces less issues into your code base. Eliminate duplicate code. Again, if you find yourself writing the same function multiple times, just take one of those out and use the one that you originally made. Just be careful not to over-engineer everything. Tip number 3, avoid comments. And this may be more of an intermediate step for some people. For some brand new learners, it is extremely helpful for them to describe what functions and what variables are doing. So I definitely wouldn't say everyone needs to avoid comments. As you become better versed in programming, this might be something to kind of take up. But the thought here is that your functions and your variables and your methods should be so descriptive that you shouldn't need comments. Your code should be self-explanatory, and comments just get thrown in there they might confuse people. We have a comment back here in our example of dirty code. It says, number of days there are hurricanes. What does that have to do with the rental car cost? So we'll take a look at this later, but hint, hint, it has nothing to do with the rental car cost. It's an old or out of date comment that is essentially just providing more complexity to our code right now. So let's get back here. If your code does require comments, that can be a signal that your code might be too confusing. And comments can become quickly outdated. So we've got a little bit of a variable here that is kind of set equal to bit of a conversion of sorts, but it's named Z. Probably not a great name, but we have this comment on the end that kind of explains what's going on. That's great, but it's better down here if we just rename the variable, and that way we don't have to have those comments, and we've got something that's almost human readable right here, where we have a variable called body mass index, and that is equal to the imperial conversion factor times the weight in pounds divided by height in inches times 2. So you could probably explain that to anyone. If someone says, hey, how do you calculate body mass index? That's probably something that would be close to what you would explain to somebody else. Tip number 4, do your due diligence. So I struggle with this on a daily basis. There are deadlines. There is the difficulty of programming, where sometimes it's easy when you get something working properly. You kind of just say, oh, thank goodness, it's working. I don't have to worry about this anymore. I don't want to see it. And you just kind of shove it out of your mind. But while you were making it work, you probably had some bad practices in there. You probably wrote some dirty code. So in doing due diligence, you kind of go back through that code and you say, how can I refactor these things? How can I take a look at my variable names and just make sure that everything is as human readable, consistent, and simple as possible? There's such a thing as called code smells and clean code patterns. And code smells are kind of a red flag in your mind. If you're reading code and you run run across the same variable or the same function twice, that might be a little flag in your mind that says, hey, that's not the cleanest code ever. I could probably refactor that, take one of those out, and it would be more consistent and more simple. At Enok, we are really big on craftsmanship and really growing your craft. That's why they have the concept of apprentices and craftsmen. And we are really big on just growing our craft, pursuing excellence in everything that we do. And software is definitely a craft. It's something that we have to work at and practice all the time. So just pursue excellence and you will be an awesome, awesome programmer. In most things in life, simple is going to be better than complex. So that applies to clean code as well. So I think we've got some time. Let's clean up some code. So we've got this function up here, and I'm going to just take a look at this. Let's start at the very top. Let's start at line 14 there. The function name is pretty self-explanatory, rental car cost. And just running through here, that D could be a little bit more self-explanatory. The C is very confusing. On line 18 through 30 here, we've got what's called a switch statement. And essentially, it's just a very complicated if statement. So we can probably clean that up. So what we're saying is, if this variable D is passed in, if it's 0, 1, 2, or 3, we're going to do whatever corresponds with that number. So we can definitely clean that up into an if statement. And then we've also got another if statement down here that we can combine. And I'm probably not going to type all this out, but I did develop just a slightly cleaner version over here, and I will bump this up so we can see. All right, can't zoom that one in. Okay, so essentially what we've boiled down here is we have taken this if statement, made another one, and then we combined it with this other if statement down here. It's still pretty confusing because we've got TC, and I don't know what that means, but I know the answer to this. So I'm gonna type in total cost. That's much more understandable. We've got this D here, and I'm gonna say days rented. Again, these are variables, so I'm using nouns. Days rented, and I'm just going to go in here and I'm going to select all of the TCs in here, switch it with total cost. Okay, take all these Ds and say days rented. All right, now if we reread this, we've got variable total cost equals the days rented times 40. And we are dealing with cost here, so that's probably a price. And we can say if the days rented is less than 3, we're just going to return that cost to you. If the days rented is between 3 and 7, we're going to take $20 off that cost. If it's over 7, we're going to take $50 off that cost. So we have our console log down here, and I'm just going to run this program. I'm going to say node clean code.js, and we get the number 40. We're passing in 1 day, so that makes sense. We rented the car for 1 day, and it costs $40 a day, so that's our total cost right there. If I were to pass in 4 days, you can run through that, and 4 days times 40 is going to be 160, I think. My math is correct. It's the days that we rented are between 3 and 7, so we're going to take $20 off that price. So we should get 120. Let's Let's run that again. Whoops. Yep, my math is wrong. We should get 140. But another example of how the computer doesn't care whether this is readable or not, if we were to back all of our changes out here. Okay, so we're back to our dirtier code right here. We were to run the same thing again. Still get $40 for 1 day and 4 days. Run this again, and we still get 140. So again, computer doesn't care. Computer understands this, but the humans and the people coming after you aren't going to understand this. This can be broken down even more. I have an example here. I did not write this one, but I got this from a website called Code Wars. And they have a lot of just really easy exercises. And what they did here was they broke everything out into its own function. So you have a function that determines your base cost. You have a function that determines your discount rate. And then you have another function that determines the total cost of all of that. And it uses those other two functions there. So again, that's probably one of the cleanest ways to write this. But let's see here. Nope. We cleaned it up a little bit, but to a certain degree, you can always refactor a little bit more. So that is an example of refactoring some clean code that you might find in the wild. So let's come down here. So why should we write clean code? We saw how it causes pain for almost everyone involved with the software. I don't know about you, but I'm all about like not causing people pain, including myself. So when it comes to software, and as software is eating the world, let's write cleaner code that cuts down on the pain for everyone involved. The benefits: your code will be neat and tidy, and you'll feel really good. It'll be easier to maintain, and your team will feel good. It will have less bugs, your users will feel good, and it won't cost as much to redo the code in the future. Company will make more money, company will feel good. To a certain degree, you can boil everything down to the Boy Scout principle. Just leave it better than you found it, and that has elements of the due diligence tip. As you're going through your code base, whether you wrote it or not, go ahead and refactor it. Go ahead and write some clean code in there. Just clean up that messiness. Some of the last things I'll say as far as other resources. To practice clean code, I would definitely recommend getting in some practice on Code Wars. They have a lot of just practice problems in there that you can go in. You can see how other people have cleaned up their code and found really clean solutions. SE Codes, can't forget about them. They are a great place to kind of learn those basics. And as you write code, you can go back, do your due diligence, and make sure everything is as clean and self-explanatory as possible. Some other resources, these are all on engineerkit.org. I have read these two books right here, Clean Coder and the Pragmatic Programmer. I'm a big fan of the Clean Coder for all developers of any kind. I don't know what EOF stands for. I didn't write this, but that is all I have for us today. So I'm going to stop sharing and we'll see what questions we have. Any questions, feel free to unmute or throw them in the chat.
Hello, Caleb.
Hey, Emmanuel.
Thanks for doing this for us. Yeah, quick question on functions, kind of. Is there, so if you're doing kind of like a larger program, is there such thing as too many functions? Like maybe your function may be too simple, or do you maybe try to do as many functions as you can to kind of make sure everything is packaged in a good way?
That is a great question. When I was first starting out, I kind of thought like, okay, we want to keep as few functions as possible. We might be doing a lot in these functions, but like, to me, that was the cleaner way to do things. As I have learned more about clean code, they really recommend kind of a single responsibility principle, or SRP. And that says that your functions, your variables, everything should only be doing one thing. So that means that all of those functions should be doing one thing. So you split out all of those functionality into its individual functions. Now, you can definitely go overboard with that, and you can spend all of your time writing single or 3-line functions that you end up like not doing a ton with your program. But if you kind of stick to that principle of single responsibility, your code will be very clean.
Okay, awesome. That's good point. Shit.
Thanks for the question.
Next, I have one more question, actually.
Yeah, fire away.
So I just started in the boot camp maybe like about a month ago.
Mm-hmm.
So we're working on React at the moment, and we're working on arrow functions.
Mm-hmm.
With arrow functions, when it comes to having a clean code and the kind of the new way of doing like ES6 and stuff, do you recommend trying to do one-liners or figure out how to do one-liners, or is it best to just make it simple where you can understand it, but also just kind of try to make it clean?
Yeah, definitely. One-liners definitely have their place. I think I couldn't really give you like a definite never do one-line arrow functions or anything like that. You will come across them where it's just like, yep, that looks clean, that makes sense. It's all about how your eye perceives it as you're reading the code. So if you can understand it in one line, fantastic, great. If you can't, or you're struggling a little bit, go ahead and split it out into multiple lines. Again, the computer's gonna read it the exact same. It's more about how do you read that? How do you perceive it?
Mm-hmm. Awesome. Okay, thank you.
Yeah, good luck with the boot camp.
Appreciate it.
Awesome. Well, if you have any additional questions, please feel free to throw those in the chat while we wrap up. But Caleb, thank you so much for your presentation. I know Katie and I were chatting in the background a little bit, and I learned, oh, good on Facebook, perfect. I learned so much and had no idea how much code was controlling, especially with that Boeing incident. I had no idea that that's what that was from. But thank you for such great information, as always. For those of you who are not on SC Code's platform, please, please, please feel free to join us for webinars like this, mentors like Caleb, information like he just shared. And we'd love to have you over on our platform, on our Slack channel. I'm going to do one last call for any questions, but if not, thank you so much for joining us. Everyone that joined, thank you for those great questions that came in. And I hope that you guys all have a wonderful long weekend and enjoy some time, however you celebrate. Thanks again, Caleb.
Absolutely. Thanks for having me. Thanks for the great questions, everyone. Hope you enjoyed it.
Thank you.